Welcome. How often have we heard discussions of whether sunspots affect global temperatures or not? Well, this video is meant to try to clear that issue up once and for all. Well, first, let us take a look at global temperatures over the last century or so. I've got the thermometer record going back to 1880 here. Some groups actually take it back to 1850, but the uncertainties on those data are much larger and would help spoil any correlation that we have. So to be fair, I've stuck with the 1880 number. I've used monthly averages because that's what we have for the sunspot numbers. And you'll note the sharp rise in global temperatures since the mid-70s. That is global warming. But also there's a lot of noise on these data. Why is that? Well, first of all, you have El Niños that produce some of the peaks here, some of the highest peaks in fact. La Niña, some of the lowest dips. And also volcanic eruptions will produce dips as well. So we have to be mindful of those sorts of events. Next, we'll take a look at the solar cycle. The sun cycles from periods when it has hardly any sunspots on the sun at all, that's solar minimum, to periods when there are large numbers of sunspots on the sun, that is solar maximum. We have sunspot data going back to about 1610, although the first 150 years of that is rather shaky data, so we tend not to use it. The sunspot cycle is approximately 11 years long. Sunspots are magnetic features and they have a polarity. That polarity reverses every sunspot cycle, so the full magnetic cycle of the sun is 22 years. Sunspot number and total solar irradiance are related. You can see them here in this particular plot on the right. The variation in total solar irradiance is approximately from 1365.5 to 1366.5, which is an overall variation of about 0.1%. This is a very small amount of variation, and the sun is a very, very weak variable star. Here is the actual sunspots data. The numbers vary from 0 all the way up to about 350. I've put the number of the solar cycles underneath each peak. So we're showing solar cycles from cycle 12 through cycle 24. We're just beginning to see the beginning of solar cycle 25 on the far right hand side of the plot. The last solar minimum was in December of 2019. The largest cycle we had was solar cycle 19, which was in 1957. However, since then, there's been a general decline in solar activity. Well, are these two quantities correlated? What I've done here is I've plotted the monthly average sunspot number against the global temperature for that same month. And we've got a scatter plot. If this was a perfect correlation, R squared, which is a parameter that measures the level of correlation, would be 1. If it was a perfect anti-correlation, it would be -1. And if there's no correlation at all, it's near 0. Our observed value is 0.00001. So that basically says there is no correlation. So, result, these two quantities are not correlated. Now, you can do a number of things with this. You can slide these backwards and forwards in case there's some sort of delay. And I've done that, and it doesn't improve the correlation at all. You can remove things like El Niño and La Niña and the volcanic eruptions. And again, it makes no difference to this scatter plot at all. There is no correlation. But what about flares and CMEs? They're correlated to the sunspot number as well, as you can see from this plot. You have sunspot number along the base here, solar 10.7 radio emission just above it, total solar radiance above that, and then we have number of C flares and X flares, and they occur mainly during solar maximum periods or periods of high solar activity. So if they are correlated with sunspot number, then we can show that they would not be correlated with the global temperatures, and so they have no effect either. The same is true for coronal mass ejections. They're correlated with sunspot number, and interestingly enough in different ways depending on which cycle you go through, but nonetheless they are correlated. So they too are proven not to be affecting our climate, in particular our temperatures. This same result rules out galactic cosmic rays as well. They are anti-correlated with the sunspot number, so thus their R2 should be -1, but it wasn't. It was a very, very low number, 0.00009. So it is not correlated, so they have no significant effect on our global temperatures. Instead of doing all this statistical analysis, I could have just gone to one of the plots that have been shown by various researchers that look like this, where we compare the change in the global temperatures, this is the temperature anomaly in red here, against total solar radiance or sunspot number. As you can see from 1960, the total solar radiance has been falling, while global temperatures have remained the same or gone up. So again, showing there is no correlation between them. So global average temperatures do not show any correlation with sunspots, total solar radiance, flares, coronal mass ejections, cosmic rays. But it does show a correlation with carbon dioxide. Again, you'll find many versions of this plot around. Here we have temperature in red going up from the mid-70s, and it's correlated very nicely with the carbon dioxide, which is shown here in yellow, going up from about 280 parts per million to 400 parts per million in that time. We could declare victory here and claim QUAT ERAT DEMONSTRANDUM, but we do have to be very careful at this point. Just as a correlation does not prove causation, a lack of correlation does not necessarily disprove causation. There are a lot of other factors involved here. However, as we have a chief suspect that fits the bill very well, namely the greenhouse gases and aerosols that we're pumping into our atmosphere, it's hard to try to find another causation that would first of all overcome the effect of the atmospheric composition, while then also reproducing the temperature variations that we see. The problem in science that a lot of these ideas have is that they're not quantitative, they're merely qualitative. And that doesn't hack it in science. With that thought, I hope you stay safe, and until next time, goodbye.